Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students, welcome to the TV learning series. I'm again Teacher Herbert. I'm going to be taking you to the lesson 2 of biology, a practical biology lesson concerning about testing food compounds. What are we testing in those food compounds? We normally test about biological molecules. And testing the biological molecules, we are testing, that is what we call food testing. This is the lesson of today. So, these are the foods we're going to test today. Number one, we're going to test about vitamin C. Number two of today, we're going to test about fats. And in fats, we're going to use the cooking oil. Students, you also have to know that these are the reagents you are going to use. The reagents or solutions that are needed for testing these food substances. Solutions. We are going to use DCPIP, what we call endrophenyl dichlorphenyl. We're also going to use, number two, we're going to use ethanol. Sometimes the ethanol, we call it to be emulsion test. Ethanol. Then in the ethanol, we're going to use ethanol. We also add water and add water. So students, I want to remind you that these are the practical part we're going to do in biology. Testing vitamin C, testing the fats. Where do you find vitamin C? Vitamin C is normally found in very many food compounds. It is found in fruits. Here it is found in fruits. There are a number of fruits we know that contains vitamin C. I have a sample of the food that contains vitamin C. This is a lemon. The lemon contains vitamin C. You also have apple. We can have orange. We can have, there are very many fruits that contains vitamin C. So you can extract vitamin C and you test the presence of vitamin C. And I can ask you, what disease can a person suffer from lack of vitamin C? Lack of vitamin C causes scurvy. So let us start our experiment. In front of me, the table has some food nutrients, and also it has some chemicals that I'm going to use. This is a prepared sample of vitamin C. I said we have an example of vitamin C. We can extract it from the lemons. The chemical I'm going to use, it is, as I mentioned, it is dichlorphenyl endrophenyl. The color of endrophenyl dichlorphenyl is blue in color. When there is a presence of vitamin C, the color of the blue of DCPIP disappears into a colorless. That will test positive that vitamin C is present in the solution. Let's start the experiment. I will start the experiment by getting the test tube. After getting the test tube, and then I add this DCPIP. The DCPIP is a test for vitamin C. I put it into a test tube. You can see in the test tube, there is presence of DCPIP. From there, you see the color of DCPIP is blue in color. If I add if I add a solution, I can say sample A that contains vitamin C, it will change from the color of you shake again gently, you shake and see if the color of the bendic solution disappears. You shake gently to try to see the color of the bendic solution of DCPIP disappears. Let us try to shake, and we observe clearly if the color turns into colorless, that one will show that there is present of vitamin C. I can say it tastes positive. You can see properly, this is the experiment we are conducting. I can see, everybody can see that the color of DCPIP of blue color has changed to a colorless. That one indicates the solution contains vitamin C. You can see it is now colorless, as you can observe clearly. It is colorless. It is colorless. Everybody can observe and see it is colorless. From the color of blue, it changes to colorless, meaning that the solution contains vitamin C. Number two, so student, you have seen that the solution tests positive. The results are positive because there is presence of vitamin C. So let's test about now the fats. Fats, I have examples of the fats I have here. I have cooking oil. Cooking oil, most of us, we know that we have to use cooking oil in very many processes. Take an example, when you are cooking food, when you are preparing food at home, we normally use the cooking oil. And you remember that cooking oil is an example of fats. So I'm going to also before I proceed with that, I also have to take a control experiment on vitamin C before I proceed with the cooking oil. Let me just use a distilled water to test if that water contains vitamin C as a control experiment. What I can say, a control experiment is an experiment that tests negatively, not tests positively. Let me just also try to do it, and then we see. Does it contain surely vitamin C, the distilled water, which is a control experiment? Let me also do a control experiment about that solution. I add my DCPIP. If I add DCPIP in the solution, let us check and see. Does that solution, we are doing it as a control experiment, does that solution changes to colorless? Okay? We try to observe and see. Let us try to observe and see. Try to observe and see. When you are observing, I remind you to take a note and write something in your book. If you say the color can change, persists, meaning the solution does not contain vitamin C. But if the color changes to colorless, it means that solution contains vitamin C. I think the color is persisting. If the color persists, I have to compare the two solutions that I have. Here I added DCPIP. Here I added water. So I'm comparing the two test tubes that I'm holding in my hands. These two test tubes, this on the left-hand side, the solution contains vitamin C. So this one does not contain vitamin C, so it tests negative. That one tests positive. That one that tests positive, the result tests positive, that one indicates the solution contains vitamin C. This one tests negative, meaning there is absence of vitamin C. Thank you. Let us go to the next experiment, which is concerning about sample testing about cooking oil. I told you we use cooking oil in very many, in our kitchen to prepare different foods. I'm going to test, can we say that the cooking oil contains fats? Okay? If you say there is presence of fats, what do we normally use? We normally use a reagent which is called the ethanol. If I say ethanol, all of you know that ethanol is an alcohol. Those who know in chemistry, this ethanol, it is an acid, but it is among of the weak acids. Among of the weak acids. So we are going to prepare and try to see, do the fats contains, do the cooking oil contains fats? Let us try and see. I will get I'm adding the dropwise. I'm adding dropwise some drops of cooking oil. From there, I have to add hydrochloric acid. We get a beaker and we add hydrochloric acid. Where can we add the hydrochloric acid? Let me just get a beaker and I add hydrochloric acid. So we add hydrochloric acid. Or we can use ethanol. So the ethanol is here to test the presence of fats in our food nutrients. So let us test and see. Put it there. From there, you add water and you shake. Add water and shake. Shake and see. Gently and see what is taking place. Down here, you see there's something like a white amyloid. That white amyloid indicates the presence of starch. There's presence of fats. So when you shake properly, see, because we know that water does not mix with oil, then that ethanol will try to make what we call a white amyloid at the bottom. So this is a white amyloid that indicates the presence of fats. White amyloid. So simply, we can say the presence of white amyloid in the test tube, as you can see down here, there is white amyloid that is going to be formed here. That one indicates the presence of fats. So let us make something that we take a note about it. You can say, let us take a note. Testing for vitamin C. All right, what do you use test vitamin C? As I said, food, you can take ascorbic acid as a food nutrient. Then from there, you can also use the DCP IP. As I said, it is endrophenol dichlorphenol. Then when vitamin C is present, the color of DCP IP, which is blue in color, changes to a colorless solution. That indicates that the solution contains vitamin C. So you can say from there, that is say it tests the results, can say, therefore, it has tested a positive result. Positive result. Then you can also say, number 2, that is when vitamin C is absent, the color of DCP-IP persists. It means it tests negative results. Then test 2, I can say this is test 1. And say this is test 1. Then test 2, we are testing about the fats. As you can see, the fats, I said, when you add the ethanol in the cooking oil, I can say in bracket, they can talk about fats and lipids. There are very many food that contains fats and lipids. We can have cooking oil, we can have G-nuts. These are food that contains oils and fats. We also don't forget about the meat, also contains fats. So if you add ethanol in the cooking oil, the color, and from adding ethanol, after add water, you can say it forms and add water is also added. You can say all the water is water is also added. You can say after adding water, it forms a white emulsion. You underline that word, which is very important. It forms a white emulsion, which confirms the presence of fats or lipids in the sample. So this one confirms positively, which confirms the presence of fats and lipids in the food sample. So it means that our sample, where we added ethanol as an alcohol, I cannot even remind you about the chemical formula of ethanol. If you say the chemical formula of ethanol, it is CH3, CH2, then hydroxide. That is the chemical formula of ethanol. This is ethanol. This is an alcohol. Sorry, this is supposed to be CH2, COH. This is supposed to be an ethanol. This ethanol can just be used for testing the presence of cooking oil or fats. So, from there, I can now make an exercise with you, and we try to see if maybe you check properly in your books, if that formula is correct, where you can even ask your teachers of chemistry to give you about the chemical formula of the ethanol. Let's have an exercise about the experiment. Students, thank you I think the lesson was very enjoyable because it involves about food nutrients. It involves about very many things that we use in our life because we know that we have to test these food nutrients and able to know their major constituent by using these chemical compounds. Let us do an exercise. I'm going to have an exercise with you. Let's have exercise. Okay. One, what is DCPIP in full? That is A, then B. What is it used to test? That is C, make the observation and conclusion. Or we call it be reduction after carrying the experiment. After carrying the experiment. Number two, you can say what chemical test is used to test fats and lipids in food nutrients. That is A, that is B. We say make a table and show your observation and the deductions. Deductions or conclusion. Think about this exercise. After thinking the exercise, then able to give me the right answers through the exercise I'm giving you. Student, I think you're enjoying the lesson. The lesson is very enjoyable because it is concerning about food and nutrients. So I want to pass through the exercise with you. I said, what is DCPIP in full? Good. DCPIP in full. These are, let us make from here. In full, you can say DCPIP. This is correction. Take a note and write that correction of the exercise. Correction of exercise. I can call it to be exercise 1. So 1 DCP IP in full we write it is dichlorphenol, endrophenol. I said, what is it used? That is A, B. It is used to test the presence of vitamin C in the food sample. Good, excellent, and that's good. 3, I said, make the observation and the deduction. You say if you add, that is C, if you add DCPI in a food sample that contains vitamin C, the color of DCPIP, which is blue in color, yes, blue in color, changes from blue to colorless, which confirms a positive result presence of vitamin C. Take that note. So in the question there is conclusion and action. Then number 2, I think we have to clean that one. We go to the part 2, which is what is the use? What do we use to test fats? What is used to test fats? Yes. We use, number 1, the answer is number 2. We use ethanol and water to test fats in the food sample. Good. Then the conclusion, what makes you make a table? The table, you have to make a table, and the table will just be very brief. We talk about this is supposed to be the reagents. And then you talk about observations. Then from the observation, you make conclusion, or we call it to be deductions. So I'm going to leave you with that exercise. You have to make, you talk about the reagents, you add like 2 drops or 2 centimeters, and then after you make your observations, and then you make a conclusion. So students, before I wind up my lesson of today, of biology, thank you for being with me in my biology lesson. I hope I will see you in the next lesson. See you.